Hi everyone. Welcome to the first recitation of this course on Python fundamentals. In this session, we will be discussing why we study Python, setup, some basic syntax, and then data structures and functions. So let's get started. Almost all deep learning code in both industry and academia is written in Python. It's simple and readable. It has a massive ecosystem of libraries and a great community support. For this course, you'll use Python across all homeworks, so it's crucial that every student is comfortable with the language and can write clean and working code. So how do we run Python? It is an interpreted language. This means it executes code line by line. Python code can be written in standalone scripts, files with a .py extension, or interactive notebooks ending in a .ipynb extension. You can write and run Python code in various environments, IDEs like VS Code and PyCharm, text editors like Sublime Text, or browser-based platforms like Google Colab or Jupyter Notebooks. For this tutorial, we are using Google Colab. You can download Python from this website by clicking here. All modern scripts and this course use Python 3, so the versions of Python go by 3.x. Once installed, you can use the pip tool to install packages. Pip is Python's package manager. You will use pip in this format, pip install and the package name. It helps you find and download code written by others, install that code into your environment, and keep it up to date. It literally stands for pip installs packages. Here is an example of me using pip to install a library called NumPy in Python. As you can see, I have also mentioned a specific version of NumPy that I want, but it's optional. Here is an example of using pip to install multiple libraries in a single command. I've already run it for you. So we are done with our setup. Now let's move on to the basic syntax in Python. So Python uses indentation to define blocks of code. So for example, here, both the print statements come under the if block because of their indentation. Comments are used to explain code and are ignored by the interpreter. In this example, this is a single line comment. This is a multi-line comment using the double quotes. And this is just a print statement which is actually executed by my interpreter. Let's talk about modules and libraries in Python. So in Python, we use the import statement to bring in external modules or libraries. Modules help us avoid rewriting code and give access to many useful tools. For example, here, I import Python's built-in math module, which provides access to many common math functions. We then use math.sqrt16 to calculate the square root of 16. A library is a collection of modules, and here is how we can import some popular libraries in Python, like NumPy, Matplotlib, Torch, OS, and Time. So as you can see, I'm using the as keyword to specify a shorthand for the NumPy library as NP so that I don't have to repeatedly write NumPy to call its functions in my code. So we'll introduce you how to use these libraries in the upcoming recitations, especially NumPy and Torch. Let's talk about data types. Python is dynamically typed, meaning you don't need to declare variable types explicitly, and the type is actually inferred at runtime. So for example, here, I assign an integer, a float, and a string all to the same variable. You can do arithmetic using Python operators. Make note of the difference between a division and a floor division in Python. So let's talk about Booleans and logical operations. In Python, Bool is a data type that can have two values, true or false. You can perform logical operations using and, or, and not. So these are useful in if statements, loops, and filtering logic. For example, here I'm able to assign two Boolean values to my variables a and b and perform logical operations as follows. Now, our third data type that we're talking about is strings. So strings are just sequences of characters. You can concatenate strings, you can repeat strings, and you can use some string methods like lower, which converts the string to a lowercase, upper, strip, split, and a few more. So strings are immutable. That means we cannot just change them in place. And here is an example of using these string methods and just printing their result. So let's talk about the four data structures in Python. That's list, tuple, dictionary, and a set. So lists are used to store multiple items in a single variable. They are ordered, changeable, and lists allow duplicate values. So this is how you create a list using simple square brackets. As you can see in this code, I have just appended a string to my list. So print and type are some built-in functions in Python, and you'll find yourself using them a lot when we'll be debugging our neural networks. I will show you a few more of these handy functions later in this notebook. The second data structure is tuple. A tuple is a collection which is ordered and unchangeable. So for example, here, I'm using it to store coordinates. Now, if I try to change my coordinate 0 to 5 here, it gives me a type error because a tuple is an immutable data type in Python. So the third data structure is dictionaries. Dictionaries use key value pairs to store data. And unlike lists or tuples, dictionaries do not rely on position, and you can just use the key to retrieve the value directly. Here is a small example of a student dictionary. I've used curly braces to create my dictionary, and I use each key value pair is represented by a key, a colon, and its value, and they are separated by commas. So this is great when you want to organize related data and access it quickly. You will be using these in your homeworks to store model configurations and metrics. Let's talk about sets. Sets are unordered collections of unique elements. So in this example, I have created a set of 1, 4, 2, 3, 2. They do not care about the order. And if I print it, you'll be able to see I have a sorted list of unique elements. Now let's talk about conditional statements. You can use if, elif, and else to control which block of code runs based on a condition. Condition just means expressions that return true or false like these, and only the first true condition block is executed and the rest are skipped. So for example, I have a negative number, I check if it's positive and print something, else I check if it's 0, then I print 0, and at the end, I print negative number. So loops are used to repeat a block of code multiple times. They are typically used when working with sequences like strings or ranges of numbers like lists. So we use a for loop when we know in advance how many times we want to repeat something. This is an example of a simple for loop in Python, which goes from 0 to a range of 5, that's 0 to n minus 5 minus 1, that's 0 to 4. And a while loop when we want more control over how many times the loop runs. So this is just a simple example where we're decreasing x by 1 in every loop. So as we saw above, range and enumerate are more built-in functions in Python. Range is used like this, and enumerate gives us both the index and the value in the loop. So it can be very handy when we want to enumerate lists. Let's talk about functions and arguments in Python. In Python, we define functions using the def keyword. Here is a simple greet function that takes a name and prints hello name. Now, to call that function, I can simply do greet and a string. So I get hello Bob as my result. So Python also has variable arguments in my Python functions by using args and quarks. So whenever I specify args and quarks inside my definition, inside my function call, I allow it to pass a variable number of either positional arguments or keyword arguments. So this feature is unique to Python as compared to like many statically typed languages where the functions are arguments are fixed. So this gives us a lot of flexibility in how we want to call a function and what we need to specify when we're calling a function. So for example, this is a simple print course info method, and ID is my fixed argument, which is always required. But anything apart from that, I can specify as my positional argument or my named keyword arguments that are always specified at the end. So for example, here, ideally, I should be specifying an ID, then my positional arguments, and then my keyword arguments. Okay, moving on. So variables are passed by reference in Python. This is an important concept and it can help you debug things in Python because, for example, here I have a list of 3 numbers. That's my original list. And I pass it to a method and I append 100 to the list. Now, outside the function, when I try to print my list, it is modified. So let's talk about classes in Python. Python is an object-oriented programming language. So everything is an object with its own properties and methods, and a class is a blueprint for creating these objects. So this is a simple example of a student class. The init method here is a constructor and it gets called implicitly whenever I try to instantiate the object of this class. So let's see an example. Here, we are instantiating an object of the student class by specifying the property of name and score for this instance. So S is now my student object, which points to an instance with name Alice and a score 95. And I can call the greet method on this S object by this. We'll talk more about classes and object-oriented programming in Python in the next part of this recitation. Let's talk about error handling. We use try, except, and finally blocks to gracefully handle our errors. We first execute everything that's in the try block. If anything goes wrong, for example, a zero division error here, it goes into the except block and we write our error handling algorithm here. Finally is always executed irrespective of whether our try block was successful or not. So these are some errors that you'll likely run into, like file not found, key error, value error, a runtime error, and a type error. I would suggest you to always Google the errors first, and then we'll talk more about how to debug these errors in the further recitations. Now, this is a simple example of the file system in Python. We are using the OS library for this. We can create folders by using the makeDirs method. We can use open to write to files, read a file using f.read, and we can use list dirs to list all the files in the folder. We can uh, check if the file exists and delete the files using the os.remove method. So we are almost at the end of this recitation. Python comes with tons of built-in functions. Mhm. So Python comes with tons of built-in functions that make your life easier. You have already seen a few like print, type, and range. Some other useful ones are like length, sum, min, max, sorted, and zip. Don't worry, you don't need to memorize all of them right now. As you write more code, you'll naturally start using these and you'll start appreciating how powerful they are. This brings us to the end of Fundamentals of Python for this course. You can also visit the official Python tutorial to read more about some Python concepts. And that's all from my side. Thank you.
Hello everyone, my name is Delphine. I'll be taking you through object-oriented programming. And before we do that, let's go through what a class is. A class is a data type that is an entire structure that includes variables and functions. When you create a class, you have these objects that are instantiated in that class. So a class bundles data together. It and functions, which are methods to operate on that data, therefore having a reusable code. So this is the basic structure of a class. So we have a cat, and then this is the constructor method, you defining the initial part, which is self main. Then you have a public attribute, that is called there, and you have a private attribute. A public attribute, you see, it's just self.name, but if it's a private one, you have a single underscore according to the PEP standard. And then you define a function here, which is this method defined back method, then you print me out. So to instantiate, meaning to create an object from that class, you have to call the function. The function can be like my dog, and then because you have a name and age, my dog is Buddy, the age is 3, and stuff like that. For public attributes like name, you can access it directly. For example, by calling my dog.name. While private ones, you have to have an underscore to signal that they should not be able to access. So for instance, you'll have my dog underscore age, right? Inheritance allows a new class to inherit attributes and methods from an existing one. So for this instance, let's try defining a base class cat, right? So this is an entire class. So we instantiate it with the attributes name and age. This is the public attribute, see? And this is a private one because it's single underscore. If you want to do name mangling, then you do a double one. See? See, this is a double one. Then you define this function, this method, define meow, then you have to print meow. Then when you want to get a private one, remember, you have to use the underscore to get it, to get the private attributes of this. Then when you instantiate again, instantiating is creating an object from that class, then you'll do, this is my cat, then you'll do this, then you print the cat name. So the cat name in this case is Whiskers. So again, if you want to get the age, because it's a private attribute, you'll get people together age. For inheritance, like you said, you are defining a subject like kitten, and that inherits from the cat. So this is cat, then this is a superclass. So it calls the parent class of the cat, but we have inheritance the kitten from, then you say, you define this function. This self name is playing with this one. Then we are overriding it so that now when you instantiate this kitten class, it will be my kitten you're trying to call. Then you call the kitten class. Then you import this name here and the toy so that when you run this, it will be able to say Fluffy is playing with a ball. So the OP found fundamentals in this case, we have abstraction where we hide complex details, exposing only essential ones. For this instance, you have this abstract method. This is a class shoe. Then we define where, then we implement it. So that when we do that, we now have sneakers are now worn. Abstraction, hide complex implementation details, right? Encapsulation is that you bundle data and methods restricting direct access. So you encapsulate like this. So this is a private attribute. Then you have your getters and setters. Mm. So you have your getters and setters, then you can be able to instantiate that and call the class. So in this type, if I call Timberland, uh, if I call boot and then I named the brand, this brand Timberland, and if I call, you set the brand again to Mr. Price, then it will be able to show you that, right? It should be able to show you Timberland and Mr. Price. For inheritance, like we said, it's a subclass that inherits from the parent. So if we have this is the parent class, basic shoe, this is a basic shoe, a child class will say this is class sandal and basic class is the parent class. Then you say this is an open toe shoe, right? Then you are able again to instantiate them, then you call them, you call the class. For the last part, polymorphism, if you remember, polymorphism, we said it enables different classes to be treated as instances of a common superclass with unique method implementation. So in this part, you see that we have a basic shoe, then we describe that basic shoe, that this is a basic shoe. Then we have lots of classes like a loafer, that inherits from the parent class basic shoe but overrides this describe button to print a different one. And then when you call it, these are also various example of overriding it. You'll find that this is how it's will be implemented. So basically, we've gone through what a class is and the 4 types of object-oriented programming: polymorphism, encapsulation. Remember the other two, inheritance and abstraction. Thank you.